Hello, CS111 students. This is my problem set video for problem set 5, task 2, concentric circles. Here's the web page, and this task is one of two tasks where you get to choose. You can do either this task 2, concentric circles, or on problem set 5, you could instead do task 3, which is on musical scales. Both exercises are designed to test your understanding of loops. This one in the context of Turtle graphics, and the other one in the context of our synth.py music module. So for this task, you'll be defining three functions, and unusually, this time you get to create your own starter file. So we did not provide a starter file, circles.py, but you have to create that file. Although we give you some code in the description, the different pieces you need to paste into that file. We wanted to give you a chance to create a file from scratch rather than always giving you some setup material. So there are three functions that you'll need to define: concentric circles, circle row, and mycircles. The first two are very specific. The last one is sort of up to you about how you want to go about it. There's an example provided in the problem set description of the header, the comment that you should have at the top of your file. This is the same comment that we supply at the top of all of the starter files, and you should fill in your name, your username, and the submission date there. We also, for this turtle-based problem, you're going to want to import turtle beads and or turtle. And we give you some example of what that code looked like just as a reminder. You could also copy paste it from any of the many other problem sets or labs that use that code. Then we immediately jump to some examples. So concentric circles is the first function you'll be defining. And these are pictures of the results from our solution code. So this is what the thing that you draw should look like. And under each picture in this table in the problem set description, there is an example of the code that was used to create it, including all of the different commands that were necessary. So we called reset to sort of clear off anything that might have been drawn before. We called no trace to make sure that it would draw basically instantly. Although remember, if you call no trace, you must call show picture. Then we called concentric circles with certain arguments in each of these four cases. And finally, we called color black before calling show picture so that you could see where the turtle was at the end. Perhaps thankfully, depending on how you felt about the previous turtle problem sets, at least for concentric circles, the turtle does not have to move anywhere at all. You can simply use the turtle beads draw circle function, and in fact you're required to use that function, to draw all of your circles without moving the turtle anywhere. The tricky part is getting the right number of circles with the right colors to draw and the right sizes. The screenshots in this part of the lab, or part of the task, and in the rest of the task as well, include the window frame so you can sort of see how big the pattern should be. And that's just in the sort of default window size. So, for example, this first example has the parameters 200, 5, the string light salmon 2, and then the string cocky 1. All together, that produces this pattern of 1, 2, 3, 4, 5 concentric circles. The innermost circle and all of the sort of every other circle going outwards from there is light salmon 2. It's sort of a pinkish color with a little bit of orange in there. And so that's the sort of first, third, and fifth circles starting from the innermost circle. And then the other circles, the other two, the second and fourth circles, are a khaki color, so like a yellowish, lighter yellow color. And the parameters 5 controls the number of circles. The two colors control the inner and outer colors. And then the first parameter, 200 in this case, controls how big the outermost circle is. Okay, there's a few more examples. I'm not going to go through each of them. Here's the description of what it should do. So it says, draws a series of concentric circles where the first parameter specifies the diameter of the outermost circle. The second parameter specifies the number of circles to draw. The third and fourth parameters specify an inner and outer color respectively. The inner color is always used for the smallest central circle, and every other color alternates between the inner color and the outer color. Um, and it leaves the turtle in the same position as it started in because it doesn't need to move the turtle anywhere. The draw circle function that you'll be using from turtlebeads.py doesn't move the turtle. So the notes on this one. Read the above rules carefully, and it's up to you to determine how to calculate the radius of the largest and smallest circles and every radius in between. Right, the first parameter specifies the diameter of the outermost circle, not the radius, the diameter. And based on that, you should be able to calculate all the values you need. That's kind of part of the problem set, is figuring that out. You should not change the pen size from the default, which is a pen size of 1. That will make your circles look weirdly different, especially if you make it some big number like 10. So just leave that at 1. There are some extra tests that actually test that your code draws the correct images, and if you change the pen size, those may fail. The inner color is always used to color the smallest circle in the center. And what that means is that the color of the outermost circle might also be the inner color if there are an odd number of circles. So it's a little bit tricky to figure out the colors. It's not as straightforward as you might like it to be. You have to use either a for loop or a while loop to draw the circle. You can use either. There are good strategies that use both kinds of loops. The order in which you draw the circles matters, right? Because whatever is drawn later covers up whatever is drawn earlier. So you have to think about that when you're thinking about the strategy for this function. We do recommend you create an iteration table to help think about strategy if you're having trouble thinking about how to create this function. And there's a link here to lecture 9, which is where we talk about that. It also mentions slides 14 to 17 specifically in that lecture. You must use draw circle to draw your circles rather than using, for example, the turtle circle function or your own code that does something else. Because we will check how many times draw circle is called and with what parameters in order to figure out if your thing is drawing the correct circles. So don't use anything other than draw circle. That's also the most convenient function to use. We recommend, right, that you go up to that table and take those pieces of code and put them into your file. It would be cool if you even put them in a test function. And we've given you in the problem set description a nice piece of code that you can copy paste into your file that even includes one of those tests, but has a definition of that testing function, and then the special if statement that means that that testing function is only going to run when you run the code, not when we're trying to grade it, and it's not going to get in our way. So you should probably test with all 4 of the examples that we gave you specifically, and you could even test with other examples if you wanted. Okay, that is part A. Part B, circle row, is going to take your concentric circles function and add multiple concentric circles together in a row. And so again, we'll be using a loop to do this. The parameters, so we have another table here with 4 different examples. And the first example just shows a circle row that has 1 concentric circle in the row. Like, okay, it's the same as concentric circles, basically. But the others have different values. And so, like, this second one is using hot pink and light sky blue 1 to create these, like, blue and pink circles. It has 3 of them in a row. The row is 600 units long, and each of the concentric circles in that row contains 10 segments within. So the arguments here are the number of circles in the row, the total length of the row, the total number of circles in each of the bullseye patterns in the row, and then the 2 colors, the inner color and the outer color, for each of those patterns. You'll notice in this second example in the table that the circles are sort of like at an angle tilted down, and also look at where the turtle is at the end. It's at the sort of first circle, which is basically back where it started, because the code that we've provided for this example, actually what it does is it turns to the right by 45 degrees, so the turtle starts facing due east at the middle of the window, and we turn to face sort of southeast, and then we leap negative 250 units. So we go sort of like backwards. Leap does that without drawing, so that we're prepared to draw a series of circles that is sort of not totally centered, but roughly centered in the window. Um, and this code produces the image shown above where the circles are at a diagonal, but also the turtle, after drawing all the circles, goes right back to where it started. So you're going to have to figure out the movement of the turtle a little bit in this part of the problem set. So again, we have a text description of what I just went through. I'm not going to go into it again because I did just describe that. But it talked about the different parameters. And I just want to note there was a typo in an earlier version that has since been fixed. But you could also figure out what the parameters are just by looking at these examples. Okay. One thing I should mention from this text description is that the first bullseye pattern in the row of concentric circles is drawn centered on the turtle's initial position. And like I mentioned, the turtle is returned to that position when the function ends. And the other circles in the row extend in whatever direction the turtle is facing at the start. So the turtle sort of moves forward to draw more circles and then comes back at the end. And then the other thing here is that each concentric circles pattern in the larger row touches the next one exactly at the edge. They sort of exactly touch each other. And so the diameter of each pattern is equal to the distance between their centers. That's sort of a useful equivalence to take advantage of. So the notes, right? Read the rules above carefully to determine how to create your concentric circles. And in particular, to determine the diameters that you'll need and the placement of each pattern. For full credit, you must use a for loop. Your circle row function must call concentric circles. I mean, why would you not? You have this function that already creates one piece, right? Just call that. But that's required. And then again, for full credit, you must maintain this turtle's position and heading as invariants, right? Which means go back to where you started when you are done. There are examples down here of how to test it, and you can also use the code above, right, from those examples in the table to test it. And it talks again about how some of those examples include movement before the circles are drawn, and that should change the position of the entire row. Okay, that is part B. Part C is mycircles, and it is pretty simple. You have to define a function called mycircles. It must be a zero parameter function because we're going to call it with just empty parentheses. If you put parameters in there, then our code that tries to test it will crash and you will not get credit. It must return none, so no return value. That's true of the other functions in this file as well. They're drawing things, right? They have side effects. They don't have a return value or a result. Your mycircles function must contain at least one for or while loop, and it must call circle row within that loop. It also must be able to run without crashing, and it should terminate within a few seconds at most, as long as no trace is turned on. It's okay if it takes longer if you're doing the sort of like speed settings where you can watch the turtle draw the circles, because that will take a while since circles take a while to draw. But with no trace turned on, don't go crazy and draw like 10,000 circle rows or something. That will take too long, and our grading script won't be able to handle it. But as long as you obey those constraints, you're free to create whatever kind of pattern you like. Totally up to you. So this is just a place where we're giving you a little bit of freedom. You can spend 5 minutes on this part, right? Write your for loop, write your circle row, don't really care what it looks like, or you could get creative and do something fancy. So that is task 2 of problem set 5, concentric circles. And remember that you have a choice between task 2 and task 3. Task 2 based on turtles, task 3 based on audio, and I will post a problem set video for task 3 as well. Thank you.